Introduction to Functions, Part 2. Example 1. f of x equals 4x plus 3 and g of x equals 3x squared are two functions. Find Part 1, f of 3, Part 2, g of minus 1, Part 3, f of 2k, Part 4, g of k minus 3. So Part 1, find f of 3. So we swap the x in the f of x function for a set of brackets, and we put 3 into the brackets. And 4 times 3 plus 3 gives us 15. Part 2, g of minus 1. So we go to our g of x function and we swap the x for a set of brackets and we put minus 1 into the brackets. And 3 times minus 1 to be squared gives us 3. Part 3, f of 2k. So we go back to our f of x function. We swap the x for a set of brackets and we put 2k into the brackets. And then we multiply out our brackets. So we get 8k plus 3. Part 4, g of k minus 3. So we go to our g of x function. We swap the x for a set of brackets and we put k minus 3 into the brackets. So we get 3 times k minus 3 to be squared, which is 3 times k minus 3 times k minus 3. Then I'm going to do my rough work up here to get k squared minus 6k plus 9. So we get 3 times k squared minus 6k plus 9, which is 3k squared minus 18k plus 27. Example 2. Determine which of the following are the graphs of functions. So the first graph, f of x, is a function, as any vertical line intersects the graph only once. So I've drawn in a vertical line. We can see that no matter where I move that vertical line, it only intersects the graph once. So this is the vertical line test. You can do this with your ruler. The second graph, g of x, is not a function. It fails the vertical line test. And there are some values of x that would not produce real values of y. So we can see it fails the vertical line test because there are 2 points of intersection. So there's only 1 point of intersection there, but from this point onwards, we get 2 points of intersection. And then we have no intersection here. Now that's okay. That doesn't stop it being a function. The important thing is that the places where it has 2 points of intersection stop it from being a function. So it's okay to have no points of intersection with your vertical line test, but you cannot have 2 points of intersection. And then part 3, h of x is a function, as any vertical line intersects the graph only once. So again, our vertical line test, no matter where we move our vertical line, it intersects the graph once and only once. And just like the second graph, there are some places where there's no point of intersection, and that's okay. When describing intervals, the parentheses shown on the right are generally used. So we have x is an element of the real number set, where x is greater or equal to a, but less than or equal to b. So we have a comma b and we have square brackets. Or we could have x as an element of the real number set where x is greater than a or less than b. So it's equal to a comma b with curved brackets. Or we could have x as an element of the real number set where x is greater or equal to a but less than b. So we'll have a comma b, but we'll have a square bracket representing greater or equal to, and we'll have a curved bracket representing less than b. So if there's a curved bracket, it does not actually equal to b, or whatever the value is. And then we can have x as an element of the real number set, where x is greater than a, but less than or equal to b. So we have a comma b with a curved bracket in front of a, because it's greater than a, so a is not actually included. And then we have a square bracket at the end of b because it's less than or equal to b. So b is included. Example 3. Examine each of the given functions and their graphs. State the domain, codomain, and range of each. And we're going to use this yellow box from the previous video to help us do it. So this is an example of a function, and it explains what each of the different parts is. So this is just one particular function. It's not any of the functions that are given in our diagrams. So our first function is f of or, so or being the real number set, maps to or of x, maps to x squared minus 2x plus 8. So we are interested in the domain, the codomain, and the range. So the domain is the set of real numbers or. So we can see in the yellow box, this is an example from the previous video, that the first part, so to the left of the first arrow, the first part has the name of the function. So in this case, it's f, and in the example, it's also f. Then we have a colon, and then we had a capital R, which stands for the real number set being the domain, and it happens to be the same in this particular function. And that's just a coincidence, it won't always be. So the first part gives us the name of the function and the domain of the function. So capital R being the real number set. And we can see that it is all the numbers on the number line, so it's highlighted in yellow. So it's -2, -1, 0, 1, 2, 3, 4, but it's also all the numbers to the left of -2, all the numbers to the right of 4, and all the numbers in between. So all the fractions, all the decimals, so all the numbers on the number line. So it's the domain is the set of real numbers, capital R, and it's all the numbers on the number line, so highlighted in yellow. So then we have in our little yellow box, the middle section represents the codomain and the input. So it's to the right of the first arrow. So to the right of this first arrow, we have a capital R as well, representing the real number set. So that is the codomain. So that's why I have codomain written here. And again, it's highlighted in yellow because it happens to be the same as the domain in this particular example. It won't always be the same. So that's the set of real numbers, capital R. So we have the codomain and then the input. And then we want to know the range. So the range I've highlighted in blue. So we have a square bracket to indicate 4 is included, comma, infinity. And we have a curved bracket. So infinity goes on forever. So we're starting our range at 4, +4. And we can see that that lines up with the minimum point on our graph. And 4, 5, 6, 7, 8, 9, and so on, up to infinity is going to give us our range. So that's why it's highlighted in blue. In our next example of a function, we have g of 0, 2 maps to r of x maps to 1 over x. So we can see it's the red curve. So it's starting up really high on, we imagine that it goes up much higher on our y-axis than this. So it shoots down and then it shoots along here and then it stops at 2. So it's only a section of this graph. So if we follow our yellow box from the previous video, so we had f of r being the name and the domain. So now we have g of 0, 2. So the name of the function is g and the domain is 0, 2. So we write it as g of the domain is equal to x as an element of the real number set, where x values are greater than 0 but less than or equal to 2. So that's why we have the curved bracket before 0 and the square bracket after 2. So it's not actually including 0, and we can see that on our graph, 0 does not actually, our graph does not touch 0 on our x-axis. So it gets closer and closer and closer and closer to 0 on the x-axis, but it never actually touches 0 on the x-axis. And then it gets up as far as 2. And obviously this graph could continue on, and it would get closer and closer and closer to the x-axis. But we're only interested in this section of the graph where it actually stops at 2. So that's why we have the square bracket there to indicate that this particular graph that we're interested in is stopping at 2. So then the codomain, so if we go back to our example from the previous video, so we had r of x, so or colon x. So this is in the center, so it's in between the two arrows. So the or represented the codomain, and then the x represented the input. So we actually have the same thing in this example. So we have or colon x, so or of x. So the or is the codomain and x is the input. So the codomain is a set of real numbers or, so capital Or. So it goes on forever. So it doesn't just stop at 2. It doesn't just include 2. So this is the set. This is the codomain, the set of real numbers Or. So g of x is equal to 1 over x. At x is equal to 2, g of 2 is equal to a half. So if we go to our x-axis, so to be honest, this graph is not drawn very accurately. If this is 2 on our x-axis, and if we're getting an output of 1 over 2, a half, which we are, because if we were to replace the x with 2, we would get a half. That should actually line up with 0.5 on our y-axis. So it's actually a bit low. But mathematically, this is correct. So g of 2 would give you a half. So therefore, the range is equal to a half comma infinity. So with a half being the lowest y value, so a half would be the lowest possible y value for this actual function. And we go up as far as we can. So we're going 1, 2, half, 1, 2, 3, 4, and then we go up to infinity. So we have a square bracket indicating that a half, it is equal to a half. So a half is the lowest possible y value or output, and infinity is the highest. So infinity, obviously, the y values just go on forever, from a half up to infinity. Our third example is h of r maps to -1, 1 with square brackets of x maps to cos x. So this is the graph of cos x. You will see this graph and this function in your trigonometry chapter, and you will get very familiar with this graph. So this is only one section of it. This actually repeats forever in each direction on the left and the right. So again, if we follow our yellow box, so we have the name and then the domain. So the name is h and the domain is or, the real number set. So I've highlighted that in yellow. So the domain is a set of real numbers or, so I've highlighted that in yellow. The codomain, next we have the codomain and the input. So we have -1, 1 is the codomain and x is the input. So the codomain is -1, 1. And then we have the rule, the output, the range. So the range is the possible y values. So we go from -1 to 1, and we have square brackets because we are including -1. And we can see that the lowest point on our graph is -1, and the highest point on our graph is 1. So all the values in between are our range. Example 4, write down the domain, codomain, and range of the following functions. F of or positive maps to or, where f of x is equal to x squared minus 4. And g of or maps to or of f of x is equal to 3x plus 2. So for part 1, so again, we're going to use our yellow box to help us. So this is from the previous video. So the domain of f is or positive, the set of positive real numbers. So again, from our yellow example, we have the name and then the domain. So the first part is always the name and the domain. Then the codomain of f is or. So the codomain comes next. It's in between the two arrows. So the codomain is or from our example 1. F of x is equal to x squared minus 4. The lowest value of f of x is -4, since x squared is always positive. So no matter what we would sub in place of x, we would always get a positive answer. So even if this was to be 0, we would have 0 minus 4, and that's the lowest value that it could be for the output. So the range of f is -4, infinity. So -4 being the lowest value on our range and up as far as infinity. Part 2, we have g of or. So the domain of g is or, the real number set, maps to or of f of x. So the codomain of g is or, the real number set, and the range of g is also or, the real number set. Note the graph of y equals x squared plus 2 is drawn in the domain -2, 1. The range is 2, 6. So this is just an example. So the domain is -2, 1. So -2 on the x-axis. And we go up as far as 1 on the y-axis. We don't go any further. Obviously, this graph could go on forever. We're just taking a section of it. And then the range is 2, 6. So starting at 2 on the y-axis and going up as far as 6 on the y-axis. So this is just an example of a piece of a graph, a piece of a function.